Let There Be Light, A Photographic Journey into the Cosmos by Ray Miller. I really enjoy astronomy. Friends ask me whether that has always been the case. Yes, I have since childhood. I've also really enjoyed putting this presentation together. As I considered which pictures to show, I decided that instead of getting the really impressive professional pictures you may have seen as taken by such telescopes as the James Webb, Hubble, or Vera Rubin telescopes, I will personalize it by using just photos that I've personally captured through my own telescopes. I also considered how technical I would make my comments. I hope I reached an okay balance. You will hear a lot of information. Some of you may try to grasp all of the details. For others, I hope you just go for the big picture, to get a feel for the ginormous sizes and distances, but mostly the beauty of what's out there. I invite you all to join me this evening for a journey into the cosmos to see the wonderful sights that God has created. On the journey, we will spend a little time considering the beginning, who, how, and when. We will see the sights in our solar system, then travel farther afield to visit stars in our own galaxy, the Milky Way. We will enjoy the sights of other galaxies and end our journey by flying past colorful nebulas. We'll be traveling really fast, so we will complete our journey in 45 minutes. However, I will give you a heads up that the first two sections will take longer than the last three. So don't get worried if midway through you might be thinking it will be an hour or more. Sound like a plan? Could someone please turn off the lights so we can see out the spaceship windows better? Good evening, ladies and gentlemen, and welcome aboard flight number, I guess it's flight number 1. This is an experimental flight. I'm afraid we've never done this before. With service from wherever you are to outer space. Please place your carry-on bag under the seat in front of you. Zip up your spacesuit, fasten your helmet and seatbelt, and ensure your seat back and folding tray table are in their full upright position. Please do not open your window. You will regret it. There is no air out there. If you're seated next to an emergency exit, oh wait, there are no emergency exits. But in spite of that oversight, I invite you to sit back, relax, and prepare for blast off in 5, 4, 3, 2, 1. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness covered the face of the deep. And the Spirit of God moved upon the face of the waters. Then God said, "Let there be light." And there was light. And God saw that the light was good. And God separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning, the first day. And God said, "Let there be a dome in the midst of the waters, and let it separate the water from the waters." So God made the dome, and separated the waters that were under the dome from the waters that were above the dome. And it was so. God called the dome sky, and there was evening, and there was morning, the second day. And God said, "Let the waters under the sky be gathered together into one place, and let the dry land appear." And it was so. God called the dry land earth, and the waters that were gathered together he called seas. And God saw that it was good. Then God said, "Let the earth put forth vegetation, plants yielding seed, and fruit trees of every kind on earth, that bear fruit with the seed in it." And it was so. The earth brought forth vegetation, plants yielding seed of every kind, and trees of every kind, bearing fruit with the seed in it. And God saw that it was good. And there was evening, and there was morning, the third day. And God said, "Let there be lights in the dome of the sky, to separate the day from the night. And let them be for signs, and for seasons, and for days and years. And let them be lights in the dome of the sky to give light upon the earth." And it was so. God made the two great lights, the greater light to rule the day, and the lesser light to rule the night, and the stars. God set them in the dome of the sky to give light upon the earth, to rule over the day and over the night, to separate the light from the darkness. And God saw that it was good. And there was evening, and there was morning, the fourth day. Creation. Who, how, and when. First, the who. Did a divine being, God, create the universe? Many scientists, likely a majority of scientists, believe the answer is no. Their main reason is because it can't be scientifically proven that God created the universe. And if they can't prove it, they will be skeptical, even to the point of disbelief. They believe the universe has evolved without any involvement of a divine being, although they can't prove that either. Rather, they have faith and believe that it's true. Some scientists, likely a minority of scientists, do believe that God created the universe. They also can't prove that. Rather, they have faith and believe that is true. I wouldn't call myself a scientist, but I have had a good bit of science education and continue to enjoy reading, listening to, and studying science. And I believe 100% that yes, God created the universe. So among believers in God, the who is a settled matter. But what about the how and the when? For those questions, there's quite a bit of disagreement, even within the church. How did God create the universe, and in what time frame? Here are some of my thoughts for you to ponder. The Bible is not a science book, and since it isn't, I believe we do God a great disservice by trying to use it as a science book. The Bible is not even a book about science. It's a book about God. But science, I believe, is also about God. God is revealed in the Bible, and God is revealed in the science of the universe that God created. What about the how question? How did God create the universe? Did God speak it into existence? Did God use evolution to create it? Not just random evolution, but God-guided evolution. I don't spend any time at all worrying about how God did it. I just base my understanding on my faith that God did create. Finally, the when question. It's very common among Christians to have an understanding that God created the universe about 6,000 to 10,000 years ago. That time frame is primarily based on the genealogies listed in the Bible. In more photos coming up, I'm going to be referencing some time periods that are much longer than 10,000 years. How do I resolve that tension? If you use the genealogies listed in the Bible as the basis to say that God created the universe just 6,000 to 10,000 years ago, you have to ignore a vast swath of things you learn by observing and studying the universe that God made. So, based on my study and understanding of the science, I have to believe that the universe is much older, approximately 13.8 billion years old. And I would bet that if you take a poll of the top 1,000 scientists in the world, both scientists who don't believe in God and those who do believe in God, not a single one of those top 1,000 scientists would disagree with that understanding of a very old, billions of years old universe. Enough on that topic. I invite you to sit back and enjoy the vastness and beauty of the universe that God created. We will start with our solar system and then go farther out into space to explore the wonders beyond. First within our own galaxy, the Milky Way, and then with the really far out realm of other galaxies. Only small glimpses and pictures. These aren't state-of-the-art, amazing, professional pictures that you might see taken by such telescopes as the James Webb, Vera Rubin, or Hubble space telescopes. Rather, they are all photos I've personally captured through my telescopes. With just a few diagrams such as this one sprinkled in to help understand the distances and sizes we're dealing with. You probably know that the center of our solar system is our very own star, the Sun. You probably also know that the Earth is a planet, one of 8 orbiting the Sun. Here's a diagram of the inner solar system showing the planets. Mercury is the closest planet to the Sun. Venus is the next one, and then Earth, the third planet from the Sun. Tonight you're going to get a flavor of the vast distances when we go exploring universes. Distances almost impossible to comprehend. The distance from the Sun to the Earth is 93 million miles. Like I said, almost too large to grasp. But that 93 million miles pales as we keep going. Here we pull back our map of the solar system to include the fourth planet, Mars. We've had to shrink the scale to get Mars onto the page. Backing out further to capture the next planet, which is Jupiter. Again, the scale has changed, so now the Earth looks very close to the Sun compared to Jupiter. Followed by Saturn. The 93 million miles from the Sun to Earth is shrinking to look pretty small. Saturn orbits almost 900 million miles out from the Sun. Keep this picture, the size of Saturn's orbit, in your mind because I'm going to refer back to it in a few minutes. Uranus is planet number 7. And Neptune is the farthest of the 8 planets. This gives you a perspective of the relative distances each planet is located from the Sun, the center of our solar system. Neptune orbits almost 3 billion miles from the Sun. That's 3,000 million miles. And on this scale, the Earth looks really close to the Sun. I warned you the distances are huge, but now let's come back much closer to home. The Moon is the Earth's only natural, that is, not human-made satellite. The Moon and all of the planets do not generate any light of their own. We see the reflection of sunlight bouncing off of the Moon's surface. It's about 1/4 the size of the Earth. The Earth is 25,000 miles around and the Moon is 6,800 miles around. As I'm sure you know, the Moon is the closest of all space bodies, approximately 240,000 miles from the Earth. But its orbit around the Earth isn't exactly round, so the distance varies from about 225,000 at its closest to 252,000 at the farthest point. I took this picture with my telescope with a magnification of 90 power, so it looks like it's about 2,700 miles away instead of 240,000. When the Moon reaches a certain point in its orbit, only a part of the near side is lit, because the Sun is shining from the side. That's a good time to observe through telescopes, especially right on the line between dark and light. Astronomers call that the terminator line. If you were standing on the Moon close to that line, the Sun would be very low on the horizon, so there would be long shadows. Just like when you're standing on the Earth at sunrise or sunset, the shadows are long. And the reason that's the best place to observe is because you can see the shadows of the mountains and craters to give them perspective. The surface of the Moon has a lot of craters. Craters have been formed by many meteors, some very large, slamming into the Moon over millions of years. The Earth has also been hit by many meteors, but on the Earth most of the craters have disappeared over time because of water and wind erosion. On the Moon there is no water and wind. Here's a zoomed-in picture of one portion of the Moon. This is using 230 power magnification, so it looks like the Moon is only a little over 1,000 miles away. That largest crater at the top center is about 150 miles across. For perspective, it's about 130 miles from Chambersburg to Harrisonburg, Virginia. With my telescopes, I've observed all 7 planets of our solar system, and I have photos of all of them. But first we need to start at the very center of our solar system. We are all very aware of our Sun. We couldn't live without it. It's very, very large. It would take about 1.3 million Earths to fill the Sun. It of course is also very hot. Its surface is about 10,000 degrees, but at its core about 27 million degrees. It's a big ball of plasma and is constantly undergoing nuclear fusion. It's a very complicated process, but to describe it in simple terms, the Sun is mostly made of hydrogen. In the core of the Sun, the pressure is so immense that the hydrogen atoms are crushed together, and 4 hydrogen atoms fuse together to become 1 atom of helium. Each of these fusions give off energy, and because there are millions and billions of those little atomic fusions, lots of energy. Every second, the Sun generates 1.5 million times more energy than all humans use in a whole year. So the Sun is a great source of energy, and is a very hot and stormy place. One product of those storms are sunspots. Those are the small dark spots you see on the surface of the Sun in this photo. I say small, but in reality that largest spot is several times larger than the Earth. The sunspots are cooler areas. I said the surface is normally about 10,000 degrees, but these sunspots are only about 5,000 degrees. Another product of the violent magnetic action on the surface is solar flares. I have a couple of pictures of solar flares shooting off the edge. These solar flares cause coronal mass ejections, or CMEs. When CMEs hit the Earth, depending on their strength, they can disrupt our communications networks. CMEs are also the cause of the beautiful aurora borealis, or northern lights. So, on to the planets. You may know that Mercury is the closest planet to the Sun and also the smallest planet, with a diameter a third the size of the Earth. Because I don't have large telescopes, all I can show you is just this red smudge of light. But hey, at least we can say that we've seen Mercury. Venus is the next planet out from the Sun, and when it reaches its brightest, is the brightest object in the sky besides the Sun and Moon. You can see that in this photo, Venus appears as a crescent. Both planets inside the Earth's orbit, Mercury and Venus, have phases just like the Moon, depending on where they are in their orbit around the Sun. In this photo, the Sun is shining from the upper right, so from our viewpoint, only that side of Venus is lit up. Because its size is very similar to the Earth, it is sometimes called our sister planet. But as we learned more about Venus, we found it's quite different, a big reason being its temperature. The average surface temperature is almost 900 degrees, making it even hotter than Mercury. This is caused by the runaway greenhouse effect from a very thick atmosphere made up of mostly carbon dioxide. The third planet from the Sun is the Earth, and the next planet out is Mars. At the closest point to Earth in its orbit, it's about 36 million miles away. This picture was taken when it was 111 million miles, and because it's only half the size of the Earth, it's very tiny in this photo. I do have a larger photo coming up soon. We Earthlings have landed more spacecraft on Mars than any other planet, but still no human astronauts. I expect sometime in the next 15 or 20 years we'll put our boots on the Martian surface. The four innermost planets are called the rocky planets because they are made of rocks. And the four outer planets, where we are going next, are called the ice giants because they are ice cold and they are giants. All four of them are composed of gases, not solid. The fifth planet from the Sun is Jupiter. And yes, I took this photo. Jupiter is also the biggest planet in the solar system. Approximately 1,300 Earths would fit inside Jupiter. It is entirely made up of gases, mostly hydrogen and helium. The bands you see are wind currents of those multicolored gases. Jupiter has 95 officially recognized moons of various sizes. In this photo you can see the four largest, Io, Callisto, Europa, and Ganymede. They are called the Galilean moons because they were first seen by the astronomer Galileo in the year 1610. He did not invent the telescope, but he was the first one to use it for astronomy. Galileo was also the first person to see the rings of the planet Saturn. And speaking of Saturn, this is easily my favorite object to view in our solar system. Again, the picture doesn't do justice to how it actually looks in the telescope. Saturn is currently 795 million miles away, which is almost its closest approach. It takes light an hour and a quarter to get here. In addition to its beautiful rings made of chunks of rock and ice, Saturn also has 274 officially recognized moons, only one of which, Titan, is large enough to see with my scope, but it isn't in this photo. Saturn is the second largest planet in our solar system, and like Jupiter is a gas giant made mostly of hydrogen and helium. The two outermost planets are Uranus and Neptune. The best I can capture with my telescopes is not much more than just a blue-green point of light. Not because they are small, they are both about 4 times as big in diameter as the Earth, but rather because they are so far away. This one is Uranus. Uranus is also another many-moons planet. Astronomers using the James Webb Telescope recently discovered the 29th. If you remember earlier, I said that Neptune is almost 3 billion miles out. Here's the best picture I have, the teeny dot in the very middle of the circle. The brighter light is the star much farther away. Neptune is so far away from the Sun that if you were there, the Sun would just be a small, pale yellow ball in the sky. It receives about 1/900th as much sunlight as does the Earth. Several times a year, an interesting thing happens called a conjunction. That's when two heavenly bodies nearly align from our viewpoint. It's especially fun when they're close enough to be able to be seen in the same field of view in my telescope. This one is of Venus and the Moon. Sometimes they are even closer, so that I can get them in the same field of view and at a higher magnification. I captured this interesting picture, although yet not a very good one. The great big body is just a small portion of the Moon, and Mars is appearing to slide just by the Moon. In some parts of the world that night, Mars actually went behind the Moon. That's called an occultation. There are various other types of smaller bodies orbiting the Sun. Dwarf planets such as Pluto, an even tinier dot about 3 billion miles away. And yes, I have been able to see Pluto. There are also meteors, chunks of rocky space debris, some several miles wide and some tiny pebbles. Several times a year there are meteor showers, times when the Earth goes plowing through the debris field of a disintegrated comet. And speaking of comets, this is a picture I captured of a comet named Tsuchinshan Atlas. Comets are cosmic snowballs of frozen water, gases, rock, and dust. They orbit our Sun and range from a few miles to tens of miles wide. When they get closer to the Sun, they heat up and spew water vapor, gases, and dust into a glowing head as big as a small planet. It also generates a tail which can extend for millions of miles. The current number of known comets is about 4,000, but there are likely billions orbiting our Sun. Some have relatively short orbits of just a year or two, and some immense. It will likely be over 80,000 years until Comet Tsuchinshan comes around again. We won't hold our breath. The photos of the Sun and the innermost planets were taken with a regular digital camera attached to one of my telescopes. I've named this scope Sully. Sully is best used for objects in our solar system. My other scope is Stella. Stella is best for viewing and photographing much further objects, especially outside of our solar system. Although Stella doesn't have as much magnifying power, it has the ability to gather light over an extended period of time, similar to a long exposure night photograph you might take with a regular camera, so it can see much dimmer objects. Okay, done with our solar system. Let's talk stars. Stars are formed by vast amounts of dust and gases gradually clumping together over hundreds of millions of years, and growing massive enough that their gravity crushes the atoms together with such force that nuclear fusion begins. That's what I described earlier in our own Sun, which of course is a star. The closest star to us, other than the Sun, is named Proxima Centauri. I don't have a photo of that star because you can only see it if you're in the southern hemisphere. It's about 25 trillion miles away. That translates to 4¼ light years. In other words, it takes the light from Proxima Centauri over 4 years to arrive. Within our solar system, I was giving you distances in thousands or millions, and with Neptune and Pluto, billions of miles. From now on, the distances are so vast that we will need to measure not in miles, but in light years. 1 light year is the distance light travels in 1 Earth year, and 1 light year is about 6 trillion miles. Distances we can hardly fathom. But keep that term light year in your mind, because I'm going to be referring to it many times through the rest of the evening. to tell you how far away things are. Remember, 1 light year equals 6 trillion miles. This photo is a star that we can see from our part of the world, and it's most likely the most well-known star. Any guesses? Polaris, also known as the North Star. It has the unique position of being directly over the North Pole. That means as the Earth rotates on its axis every 24 hours, the North Star always maintains its spot in the sky. And here's another tidbit you may not know. The North Star always tells you which latitude you are on the Earth. If it is 35 degrees up from the horizon, that means you are at 35 degrees north latitude on the globe. That's why it's been such a valuable navigation tool for millennia. Over a 24-hour period, all of the other stars make a circle around the North Star. In actuality, they don't really travel around the North Star. It's just that from our perspective, it appears that they do, because of the Earth's rotation on its axis. How do you find Polaris if you don't know which way is north? First, you find the Big Dipper and the 2 stars at the end of the bowl. Extend an imaginary line between those 2 stars and keep going about 5 times as far. Voila, there is Polaris. Did you also know that Polaris is the star at the end of the handle of the Little Dipper? The Little Dipper is fainter and harder to find. Here's another interesting tidbit with the Big Dipper. The handle of the Big Dipper is made up of 3 stars. The middle star is Mizar. And if you use a telescope to look at Mizar, you will find that what you see as 1 star with your naked eye is actually a double star. Mizar is the brighter star, and Alcor is located up and a little bit to the right. Here's another double star named Albireo. With the naked eye, it appears as just 1 star, but with the telescope you see there are 2. Notice the difference in color. The gold one is considered a red giant, which means it is an old star. The blue one is a younger star. They are about 420 light years away. Our sun is a star, but of course a really close one, close in astronomical terms. And it looks so big and dominates our sky view because it is so close. But as stars go, it's a pretty small one. This is a diagram of how our star compares in size. Look in the upper left quadrant, and you see the relative sizes of a small star named Wolf 359, the Sun, and a larger star, Sirius. Sirius is the brightest star in our sky, not because it's a large star, but because it's relatively close. Now move 1 box to the right. In order to show larger stars on our diagram, we need to shrink the scale. So Sirius is now the tiny one, and beside it is the relative size of Arcturus and Aldebaran. Let's shrink the scale some more in the lower left quadrant, so that Aldebaran is now tiny, and next to it are Antares and Betelgeuse. Finally, 1 more change in scale, making Betelgeuse small, compared to the really biggies. Do you remember a few minutes ago when I showed you the diagram of distances the planets orbit from the Sun? If you take this largest star, VY Canis Major, and plop it down at the middle of our solar system, the star would cover all of Jupiter's orbit and 70% of Saturn's. Mind-blowing. And now this begs the question, how many stars are there? On a dark, clear night, in a really dark place away from city lights, a person with good eyesight can see about 2,000 with the naked eye. But how many stars are there in total? So many and so far away it is impossible to count. The best estimates are around 1 with 23 zeros. This is a cluster of stars in one area of our sky called the Hercules Globular Cluster. Although they look close to each other, they really aren't that close. The Hercules Cluster, which is the bright area in the middle, has over 100,000 stars, and it's located about 25,000 light years away, or 25,000 times 6 trillion miles. That's 150 with 12 zeros. Yikes. Our solar system is made up of planets and other objects that orbit our sun. Planets that orbit other stars are called exoplanets. More than 6,000 exoplanets have already been discovered. Many, perhaps even most of the other stars have 1 or more exoplanets orbiting them. All of the things in our neighborhood of the universe make up our galaxy. This is a long exposure I took with my camera, not through a telescope, when I visited a dark sky park in the mountains of northern Pennsylvania. The Milky Way of light you see arcing across the sky is our galaxy, named the Milky Way, and it can only be seen if you're in a relatively dark area. The Milky Way is a spiral galaxy. At the very center of the spiral galaxy is a humongous black hole. Because of that black hole's extreme gravitational pull, it keeps all of the stars of our galaxy orbiting around it in a big spiral, kind of like a whirlpool. Towards the center of the galaxy, there are a lot more stars than farther out. We're located about halfway between the center and the edge of the spiral. The galaxy is about 100 million light years across. That light, the Milky Way, you see arcing across the sky is not clouds, but rather the light of hundreds of millions of stars we see when we're looking toward and through the center of the galaxy. Stars so far away you can't pick them out individually. The dark bands running alongside the Milky Way are dark cosmic dust blocking the view of stars behind it. And the individual lights you can see are stars that are closer to us. I can't show you a picture of the spiral of the Milky Way because we're in the midst of it, but it would look similar to some other spiral galaxies whose photos I will show you shortly. One of the closest galaxies to the Milky Way is the Andromeda Galaxy. When I say close, you need to keep in mind the vast distances I spoke of earlier. Now we are truly getting far away. Andromeda is 2.5 million light years away. To say it differently, the light we're seeing now left there 2.5 million years ago. While our Milky Way is estimated to have 200 billion stars, the Andromeda Galaxy boasts more than 1 trillion. And that really bright area in the middle is made up of lots and lots of individual stars too, far away to pick out individually. All of the other lights sprinkled through the picture are actually stars in the foreground, stars in our own galaxy. That will also be the case in the other galaxy photos coming up. Stars in other galaxies are too far away to be seen individually. How many galaxies are in the universe? Probably hundreds of billion, perhaps 1 trillion or more. I'm going to pick up the pace and show you the best galaxy pictures I've captured without spending much time on each one. This is the Cigar Galaxy. This galaxy is an extremely bright and active one. At the center, it is forming new stars at 10 times the frequency as does our Milky Way. It's a spiral galaxy, but we're looking at it edge-on. It has about 30 billion stars and is 12 million light years distant. Bode's Galaxy, also 12 million light years distant, but in a different direction. In the middle of it, there's a massive black hole just as in our galaxy. There's likely a black hole at the center of all spiral galaxies. This is the Black Eye Galaxy. Don't ask me how they get their names. Bode's Galaxy was discovered by an astronomer named Bode, but many get their name from their appearance. But I don't see a black eye here. Maybe you can. It's about 17 million light years away and about half the size of our Milky Way galaxy. The Sombrero Galaxy. Here I do see how it got its name. See the bulge in the middle, the crown of the sombrero? But it's a huge sombrero, 50,000 light years wide. In miles, that's a 3 with 16 zeros. And it's about 31 million light years distant. It is also a spiral galaxy, but we see it edge-on. This is the Triangulum Galaxy, another galaxy about half the size of the Milky Way. You're seeing approximately 50 billion stars in this photo. A relatively close galaxy, only 3 million light years from us. The Pinwheel Galaxy is also a very beautiful one and is also very large. It is 170,000 light years across the width of it, nearly twice as big as the Milky Way. And it contains approximately 1 trillion stars, and it's located 25 million light years from Earth. This beautiful galaxy is the Sculptor Galaxy. It's a starburst galaxy, which means it's currently undergoing a period of intense star formation. It's one of the most easily viewed galaxies after the Andromeda Galaxy. You can even find it with binoculars if you know where you're looking, but in binoculars it will just be a smudge of light, nothing like this. This galaxy is probably my favorite, because it's a two for the price of one. The two galaxies are close enough that the Whirlpool Galaxy, which is the larger one, will likely eventually gobble up the smaller one. Whirlpool is 31 million light years away. I've saved this photo for the last of the galaxy photos, not because of how impressive it looks. Stephan's Quintet is a grouping of 5 galaxies. The arrows point to the 5 galaxies. The bottom one is actually 2 galaxies that are merging. The bright lights in the middle of the galaxy are not a part of the galaxy, but are stars in the foreground between us and the galaxy. Stars in our own galaxy much closer to us. What's impressive about this photo? The Stephan's Quintet are the farthest objects I've been able to get with my small telescope. They are 300 million light years away. In miles, that's 18 with 20 zeros. Have I blown your minds yet? For the last set of photos, we're going to come back much closer to home, back into our Milky Way galaxy. Stars and planets are beautiful as individual lights in the vast darkness of space. Between those planets and stars are vast distances of empty space. Except, while there are certainly huge distances with very little in it, it isn't all empty space. With a good telescope and long exposure photography, there are amazingly beautiful, colorful nebulas. Nebulas, the plural can also be pronounced nebulae, are made up primarily of cosmic dust and ionized hydrogen, which gives them their color. They are an integral part of the life cycle of stars. Not only are they the material that forms new stars, but many of them are also what is left after the death of a star. Nebulas are primarily formed in 3 ways. One way is simply an accumulation of cosmic matter pulled together by gravity. A second method is in the final stages of an average to small size star. This is the future of our Sun. In about 5 billion years, the Sun will start slowly expanding as it runs out of fuel. It will grow into a red giant, large enough that it will consume Mercury, Venus, and possibly even the Earth. In that process, it will throw off some of its material, which will form a nebula. The Sun will then shrink to become a white dwarf star. And the third main way nebulas are formed is by a supernova. The most spectacular end of a star's life is that of the giant stars. They will violently explode in a matter of just a few weeks, rather than the billions of years for smaller stars like the Sun. That is a supernova. After the supernova explosion blows out all the material making the nebula, the remaining matter in the star will collapse to become a very dense and compact neutron star. And if the star is sufficiently large, so that it has a larger amount of matter left over, it will collapse even more and form a black hole. The smudge of matter in the middle of this photo is the Crab Nebula. It was formed as a result of a supernova recorded by Chinese, Japanese, Arab, and Mayan astronomers in the year 1054. It was so bright they could see the supernova even in the daytime for 23 days. The nebulas we see are all located in our own galaxy, so not at the ginormous distances of galaxies. As with the galaxies, I will move quickly through the images, making only a few comments. I believe you will agree that these are the best of the photos, so I invite you to sit and soak in their beauty. This colorful blue circle in the middle of the photo is the Ring Nebula. It is 2,570 light years from Earth. The Dumbbell Nebula, also referred to as the Hourglass Nebula. Although it's located 1,250 light years from Earth, it's estimated to be only 3,000 to 4,000 years old. So we're seeing it as it appeared in its nebula childhood years. The Helix Nebula. It is one of the closest nebulas, about 650 light years away. It's also sometimes called the Eye of Sauron. You Lord of the Rings fans may recognize that reference. The Eastern Veil Nebula. Take a moment to enjoy the beautiful wisps of color spreading across the photo. It was formed by a supernova caused by a star 20 times more massive than the Sun, exploding more than 10,000 years ago. The Western Veil Nebula is a companion nebula in the same neighborhood of the sky, formed by the same supernova. The two Veil nebulas are about 2,400 light years away, and the Western Veil Nebula is also called the Witch's Broom Nebula. This is the Running Man Nebula. If you use your imagination, you might see that the dark area in the middle has the shape of a running man, with his head to the right. If I would have taken the picture 6 hours later, he would have been upright. The orientation changes throughout the night as the Earth rotates. That's one thing you learn as you study the night sky. Everything moves in a very organized way, except the North Star. The Horsehead Nebula. Again, in the dark shape in the middle, you can see the horsehead looking up. This very colorful nebula is the Flame Nebula, 1,350 light years away. The dark area in the middle, as was the dark area in the Running Man and Horsehead nebulas, is not an absence of the colorful gases that make up the nebula, but is actually a large bunch of dark space dust in front of the nebula, blocking our view. The very bright star on the right is Alnitak, which is one of the 3 bright stars that make up Orion's belt in the Orion constellation. And speaking of Orion, right next door is the Orion Nebula, one of the largest and brightest nebulas in the sky. It is too dim to be seen with the naked eye, but from our point of view it actually covers an area of the sky quite large, about twice as big as the Moon. We're nearing the end of our cosmic journey. This is the Trifid Nebula. While it was most likely made by the explosion of a red giant star 300,000 years ago, it is now a star-forming nebula, compacting back together and is reforming smaller new stars. The Eagle Nebula spans about 7,500 light years across and is located about 7,000 light years away. It was discovered in 1745. The Hubble Space Telescope has taken amazing photos of the Eagle. One of the most famous is a zoomed-in photo of the very small dark checkmark shape at the very middle of the nebula. That area is named the Pillars of Creation, not because it has anything to do with the creation account in Genesis, but rather it is an area that is actively birthing new stars. So we have opportunity to see stars in the various stages of birth and growth. The Lagoon Nebula is 5,200 light years distant. So the light we see in this photo actually left there 5,200 years ago. Just as the Trifid Nebula seen earlier, this nebula is also an older one, and stars are reforming out of its gases. It contains some relatively young stars, only 2 million years old. My last photo is of the Omega Nebula. Fitting to end my presentation with this, because Omega is the last letter of the Greek alphabet. It's one of the brightest regions in our galaxy. The colors of the ionized gases are, I believe, absolutely stunning, and a good image for you to take with you. The galaxies and nebulae we've seen tonight are too dim to be seen with our naked eye, but with the technology of telescopes, we can enjoy these wonderful views of God's creation, views that only strengthen my belief that God created them. We began with Genesis 1, we'll end with Psalm 148. Alleluia! Praise Yahweh from the heavens. Praise God in the heights. Praise God, all you angels. Praise God, all you hosts. Praise God, sun and moon. Praise God, all you shining stars. Praise God, you highest heavens. Let them praise the name of Yahweh. I hope you enjoyed this tour of the universe half as much as I did in being your tour guide.